Okay, hi everyone, welcome back to this video series on data centers. The IP routing process is fairly simple and doesn't change regardless of the size of your network. For example, we'll use figure 9.2 to describe step by step what happens when host A wants to communicate with host B on a different network. In this example, a user on host A pings host B's IP address. Routing doesn't get simpler than this, but it still involves a lot of steps. Let's work through them. Internet Control Message Protocol ICMP creates an echo request payload, which is just the alphabet in the data field. ICMP hands that payload to Internet Protocol IP, which then creates a packet. At a minimum, this packet contains an IP source address, an IP destination address, and a protocol field with 01H. Remember that Cisco likes to use 0x in front of hex characters, so this could look like 0x01. All that tells the receiving host to whom it should hand the payload when the destination is reached, in this example ICMP. Once the packet is created, IP determines whether the destination IP address is on the local network or a remote site. Since IP determines that this is a remote request, the packet needs to be sent to the default gateway so that it can be routed to the remote network. The computer then determines from its configuration the default gateway. The default gateway of host 127.16.10.2. Host A is configured to 172.16.10.1. For this packet to be sent to the default gateway, the hardware address of the router's interface Ethernet 3/1 configured with the IP address of 172.16.10.1 must be known. Why? So the packet can be handled down to the data link layer, framed and sent to the router's interface that's connected to the 172.16.10.1 network. Because hosts communicate only via hardware address on the local LAN, it's important to recognize that for host A to communicate with host B, it has to send packets to the media access control MAC address of the default gateway on the local network. 6. Next, the address resolution protocol ARP cache on the host is checked to see if the IP address of the default gateway has already been resolved to a hardware address. If it has, the packet is then free to be handed to the data link layer for framing. The hardware destination address is also handed down with the packet. To view the ARP cache on your host, use the following command: C \ARP A interface 172.16.10.2 0x3 internet address physical address type 172.16.10.1 0015050631B0 dynamic. If the hardware address isn't already in the ARP cache of the host, an ARP broadcast is sent out onto the local network to search for the hardware address of 172.16.10.1. The router responds to the request and provides the hardware address of Ethernet 3/1, and the host caches this address. Once the packet and the destination hardware address are handled to the data link layer, the LAN driver is used to provide media access via the type of LAN being used, in this example Ethernet. A frame is then generated encapsulating the packet with control information. Within that frame are the hardware destination and the source address, plus in this case an ether type field that describes the network layer protocol that handled the packet to the data link layer, in this instance IP. At the end of the frame is something called a frame check sequence FCS field that houses the result of the cyclical redundancy check. The frame would look something like what I've detailed in figure 9.3. It contains host A's hardware MAC address and the destination hardware address of the default gateway. It does not include the remote host's MAC address, destination MAC address, source MAC address, ether type field packet, FCSC or C, router's E0 MAC address, host A MAC address. Once the frame is completed, it's handed down to the physical layer to be put on the physical medium, in this example twisted pair wire 1 bit at a time. 9. Every device in the collision domain receives these bits and builds the frame. They each run a CRC and check the answer in the FCS field. If the answers don't match, the name is discarded. If the CRC matches, then the hardware and destination address is checked to see if it matches to, which in this example is the router's interface Ethernet 3/1. If it's a match, then the ether type field is checked to find the protocol used at the network layer. 10. The packet is pulled from the frame and what is left of the frame is discarded. The packet is handed down to the protocol listed in the ether type field. It's given to IP. 11. IP receives the packet and checks the IP destination address. Since the packet's destination address doesn't match any of the addresses configured on the receiving router itself, the router will look up the destination IP network address in its routing table. 12. The routing table must have an entry for the network 172.16.20.0, other packet will be discarded immediately and an ICMP message will be sent back to the originating device with a destination network unreadable message. 13. If the router does find an entry for the destination network in its table, the packet is switched to the exit interface, in this example interface Ethernet 3.2. The output below displays the lab A router's routing table. The C means directly connected. No routing protocols are needed in this network since all networks, all two of them, are directly attached. Nexus 7K config if show IP route output cut 172.16.10.0/24 ubest mbest 1/4/0 attached via 172.16.10.1 ETH3/1 0/1 01:15:59 direct 172.16.10.1/32 ubest mbest 1/0 attached via 172.16.10.1 ETH3/4/1 0/0/01:15:59 local 172.16.20.0/24 ubest mbest 1/0 attached via 172.16.20.1 ETH3/2 0/0/00:0019 direct 172.16.20.1/32 ubest mbest 1/0 attached via 172.16.20.1 ETH3/2 0/0/00:19 local. 15. The router's packet switches the packet to the Ethernet 3.2 buffer. 15. The Ethernet 3.2 buffer needs to know the hardware address of the destination host and first checks the ARP cache. If the hardware address of host B has already been resolved and is in the router's ARP cache, then the packet and the hardware address are handed down to the data link layer to be framed. Let's take a look at the ARP cache on the lab A router by using the show IP or ARP command. Nexus 7k config if hash ship ARP IP ARP table for context default total number of entries 6 address age MAC address interface 172.10.2 00114.13.1937.e978 Ethernet 3/1 172.16.20.2 00.15.f9b6.c8 Ethernet 3/4/2. From the output above, we can see that the router knows the 172.16.10.2 host A and 172.16.20.2 host B hardware addresses. Cisco iOS routers will keep an entry in the ARP table for 4 hours. Nexus defaults to 25 minutes. If the hardware address has not already been resolved, the router sends an ARP request to E3/2 looking for the hardware address of 172.16.20.2. Host B responds with its hardware address, and the packet and destination hardware address are both sent to the data link layer for framing. 16. The data link layer creates a frame with the destination and source hardware addresses, ether type field and FCS field at the end. The frame is handed to the physical layer to be sent out on the physical medium 1 bit at a time. 17. Host B receives the frame and immediately returns a CRC. If the result matches what's in the FCS field, the hardware destination address is then checked. If the host finds a match, the ether type field is then checked to determine the protocol that the packet should be handed to at the network layer. IP in this example 18 at the network layer IP receives the packet and runs a CRC on the IP header. If that passes, IP then checks the destination address. Since there's finally a match made, the protocol field is checked to find out whom the payload should be given to. 19. The payload is handed to ICMP, which understands that this is an echo request. ICMP responds to this by immediately disregarding the packet and generating a new payload as an echo reply. 20. A packet is then created including the source and destination address, protocol field and payload. The destination device is now host A. 21. IP then checks to see whether the destination IP address is a device on the local LAN or on a remote network. Since the destination device is on a remote network, the packet needs to be sent to the default gateway. 22. The default gateway IP address is found in the registry of the Windows device, and the ARP cache is checked to see if the hardware address has already been resolved from an IP address. Once the hardware address on the default gateway is found, the packet and destination hardware address are handed down to the data link layer for framing. 24. The data link layer frames a packet of information and includes the following in the header: the destination and source hardware addresses, the ether type field with 0x0800 IP in it, the FCS field with the CRC result in tow. 25. The frame is handed down to the physical layer to be sent out over the network medium 1 bit at a time. 26. The router's ether 3/1 interface receives the bits and builds a frame. The CRC is run and the FCS field is checked to make sure the answers match. 27. Once the CRC is found to be okay, the hardware destination address is checked. Since the router's interface is a match, the packet is pulled from the frame and the ether type field is checked to see what protocol at the network layer the packet should be delivered to. 28. The protocol is determined to be IP, so it gets the packet IP, runs a CRC check on the IP header first and then checks the destination IP address. 29. In this case, the router does know how to get to network 172.16.10.1. The exit interface is Ethernet 3/1, so the packet is switched to interface Ethernet 3/1. 30. The router checks the ARP cache to determine whether the hardware address for 172.16.10.2 has already been resolved. 31. Since the hardware address of 172.16.10.2 is already cached from the originating trip to host B, the hardware address and packet are handed down to the data link layer. 32. The data link layer builds a frame with the destination hardware address and source hardware address and then puts IP in the ether type field. A CRC is run on the frame and the result is placed in the FCS field. 33. The frame is then handed to the physical layer to be sent out to the local network 1 bit at a time. 34. The destination host receives the frame, runs a CRC, checks the destination hardware address and looks in the ether type field to find out whom the packet to. 35. IP is the designated receiver, and after the packet is handed to IP at the network layer, it checks the protocol field for further direction. IP finds instructions to give the payload to ICMP, and ICMP determines the packet to be an ICMP packet reply. 36. ICMP acknowledges that it has received the reply by sending an exclamation point to the user interface. ICMP then attempts to send 4 more echo requests to the destination host. You've just experienced Todd's 36 easy steps to understanding IP routing. The key point to understand here is that if you had a much larger network, the process would be the same. In a really big internetwork, the packet just goes through more hoops before it finds the destination host. It's super important to remember that when host A sends a packet to host B, the destination hardware address used by the default gateway's Ethernet interface. Why? Because frames can't be placed on remote networks, only local networks. So packets destined for remote networks must go through the default gateway. Let's take a look at host ARP's cache now. CARP minus A interface 172.16.10.2 0x3 internet address physical address type 172.16.10.1 001505 0631B0 dynamic 172.16.20.1 0015050631B0 dynamic. Did you notice that the hardware MAC address that host A uses to get to host B in the lab A E3/1 interface, hardware addresses are always local, they never pass a router's interface. So I'm going to leave this video here for today. If you like listening, please consider like, sharing and subscribing. Thank you.